going to look at two problems here. We're going to find the area under the curve 12 over x on the interval 1 to 9 using 4 rectangles. We talked about the rectangles last time. And L means we're going to use the left endpoints. And then we're going to do square root of x on a different interval. And we're going to do R3, meaning right endpoints with 3 intervals or 3 rectangles. So let's take a look at our region here. We're starting at an x value of 1 and we're going to an x value of 9. We're going to divide that up into 4 rectangles. So that's 1, that's 9, that'll be 5 and 7 and 3. And we're going to treat each of these as a rectangle, and we're going to use the value of the function at the left endpoint of the interval. So for the interval from 1 to 3, 1 is the left endpoint. We're going to plug 1 into the function and get the height from that. And then we're going to plug 3 in, and then 5, and then 7. 1 for each of our rectangles. So first we need to consider the width of the rectangle. Each of these rectangles has the same width, and it's the length of that interval, right? From 1 to 9 is 8 units, divided by 4 would be 2. So we're going to be multiplying each of these heights by 2. Why not factor that out in front just like we did the 10 seconds in that example earlier, or I guess it was 10 minutes. So each of these is going to have a width of 2. The height of the first one is going to be 12 over 1. Again, because that's the value of the function at the left endpoint of the rectangle, 12 divided by whatever the x value is. And then we're going to have 12 over 3. And then we'll have 12 over 5. We have 12 over 7. Right. So the first rectangle we're finding is going to be that one, width of 2 times the height of 12, width of 2 times the height of 4, and then width of 2 times 12 over 5 and 12 over 7. So again, I'm not going to plug this into the calculator because I don't think there's anything to be gained from you watching me plug these numbers in. There will be something we'll do in the calculator soon, but I don't think this one's particularly worth it. You should get an answer of what's that going to be. That's going to be 24 plus 8. So I'm going to round that off. That's 12. Well, that's not rounded off yet. 12 divided by 3 is 4. 12 divided by 5 is going to be roughly 2-ish. And 12 divided by 7 is again going to be roughly 2-ish. Oh, this one's a little less than 2. This one's a little bigger than 2. So if we plug 2 in for each, we'll be fairly close to the actual value. So get 2 times 12, 13, 14, 15, 16, 17, 18, 19, 20. 2 times 20, roughly 40. And if we're talking about our actual area under the curve here, obviously this is going to be a fairly gross overestimate because it's including all of these little triangle pieces right here that should not be included. But it is an estimate for the moment. We'll talk later about how to make that more accurate and finally 100% accurate by using more rectangles. Let's look at this one. We've got the square root of x. That's the graph on 0 to 9. And we want to use 3 rectangles with right endpoints. Okay, the R means right, just like L meant left there, and 3 for the number of rectangles. So we've got 0, 3, 6, and 9 are our relevant numbers here. And for the first rectangle, we're going to use the height at the right-hand side. So this is going to be an overestimate just like the other one was. And we have a width of 3 here with a height of the square root of 3. So the width is going to be the same for each of our rectangles. The height of the first one is going to be square root of 3. The height of the second one is going to be square root of 6. The height of the third one will be the square root of 9. So again, this isn't going to work out terribly nicely, but if we use a 2 for that and a 2 for that and a 3 for that, 2 plus 2 plus 3 is 7. 3 times 7, 21-ish. Again, you can put that in the calculator and get a more accurate estimate, and that is going to be a little bit bigger than the actual value of the the area under the curve because, again, we're counting those little rectangles when we shouldn't be. That's it for this one. Next time, we're going to take just one example and look at it in a little bit more depth.